Structural engineering: a bridge collapsing, a skyscraper swaying in the wind, a dam overflowing. We live in a world of structures. Bridges, buildings, tunnels, dams. They shape our cities, connect our communities, and define our landscape. But what happens when these structures fail? What are the forces at play that can cause them to collapse, sway, or overflow? Welcome to the fascinating world of structural engineering, where we explore the science and art of designing and building structures that can withstand the forces of nature and the test of time. In this video, we'll take a deep dive into the principles of structural engineering. We'll explore the different types of forces that act on structures, the materials we use to build them, and the methods we use to analyze their stability and strength. We'll also look at some of the most iconic and innovative structures in the world, and we'll meet some of the brilliant minds behind them. So, whether you're a student of engineering, a structural engineering, observer of the built environment, or simply someone who's curious about how things work, this video is for you. Get ready to be amazed by the power of structural engineering. Let's start with the basics. What is structural engineering exactly? Structural engineering is a branch of civil engineering that deals with the design, construction, and maintenance of structures. 1. These structures can be anything from buildings and bridges to tunnels and dams. The primary goal of structural engineering is to ensure that structures are safe and stable, and that they can withstand the forces that are applied to them. These forces can include gravity, wind, snow, earthquakes, and even the weight of the structure itself. To achieve this goal, structural engineers use a variety of tools and techniques. They use mathematics and physics to analyze the forces acting on a structure, and they use computer models to simulate how a structure will behave under different conditions. Also use their knowledge of materials science to select the right materials for the job. The materials used in structural engineering must be strong, durable, and able to resist the forces that will be applied to them. Some of the most common materials used in structural engineering include steel, concrete, timber, and masonry. Once the design is complete, structural engineers oversee the construction process to ensure that the structure is built according to the plans. They also monitor the structure over time to ensure that it remains safe and stable. Now that we know what structural engineering is, let's take a look at some of the different types of structures that structural engineers design. Buildings are one of the most common types of structures. Structural engineers design buildings of all shapes and sizes, from small houses to massive skyscrapers. Bridges are another common type of structure. Structural engineers design bridges to span all kinds of obstacles, from rivers and valleys to highways and railways. Tunnels are also designed by structural engineers. Tunnels can be used for transportation, water conveyance, or even mining. Dams are another important type of structure. Structural engineers design dams to impound water for irrigation, flood control, or hydroelectric power generation. As you can see, structural engineers play a vital role in our society. They are responsible for the safety and stability of the structures we use every day. Now, let's take a closer look at some of the forces that act on structures. Gravity is one of the most important forces. Gravity pulls everything towards the center of the Earth, and this force can cause structures to collapse if they are not properly designed. Wind is another important force. Wind can exert a significant force on structures, especially tall buildings and bridges. Snow is another force that can affect structures. Snow can accumulate on roofs and other surfaces, and its weight can cause structures to collapse. Earthquakes are another force that can have a devastating impact on structures. Earthquakes can cause the ground to shake violently, and this can cause structures to collapse or even overturn. Structural engineers use a variety of techniques to design structures that can withstand these forces. They use their knowledge of mathematics and physics to calculate the forces that will be applied to a structure, and they use computer models to simulate how a structure will behave under different conditions. They also use their knowledge of materials science to select the right materials for the job. The materials used in structural engineering must be strong, durable, and able to resist the forces that will be applied to them. Some of the most common materials used in structural engineering include steel, concrete, timber, and masonry. Once the design is complete, structural engineers oversee the construction process to ensure that the structure is built according to the plans. They also monitor the structure over time to ensure that it remains safe and stable. Now, let's take a look at some of the most iconic and innovative structures in the world. The Golden Gate Bridge is one of the most famous bridges in the world. It is a suspension bridge that spans the Golden Gate Strait in San Francisco. The Burj Khalifa is the tallest building in the world. It is a skyscraper that is located in Dubai, United Arab Emirates. The Panama Canal is one of the most important waterways in the world. It is a canal that connects the Atlantic Ocean and the Pacific Ocean. These are just a few of the many amazing structures that structural engineers have designed and built. Structural engineers are constantly innovating and developing new ways to design and build structures. They are using new materials and new technologies to create structures that are stronger, more durable, and more sustainable. They are also working to develop new ways to protect structures from the forces of nature, such as earthquakes and hurricanes. The future of structural engineering is bright. Structural engineers will continue to play a vital role in our society by designing and building the structures we need to live, work, and play. In this video, we've taken a look at the fascinating world of structural engineering. We've explored the principles of structural engineering, the different types of structures that structural engineers design, and the forces that act on structures. We've also looked at some of the most iconic and innovative structures in the world, and we've met some of the brilliant minds behind them. I hope you've enjoyed this video. If you're interested in